Hello everyone, let's practice solving some trig equations. We ain't talking about the game, we're talking about practice. So first, I'm going to divide by 2. I'm going to say cosine of x equals 1/2. Oh, cosine of x plus 1 equals 1/2. Plus 1 equals 1/2. Then I'll subtract 1, and I have cosine of x equals 1/2 minus 2/2 is negative 1/2. So what I need to do is figure out where cosine is negative 1/2. So cosine is negative over here. And if the x is the short leg, that means the y is the long leg. So these are 60-degree reference angles. So where does this happen? This happens at, this is 2 pi over 3. And then that's 4 pi over 3. And when it says all solutions, then I'm going to say plus 2 pi n. And since these can't be condensed because they're not pi radians apart from each other, or there's nothing going on the other side, that's the best answer. Let's just leave it alone. All right, let's try another one. This one's kind of weird because it says 4 tangent theta and 2 tangent theta. What you got to realize is that these are like terms. I'm going to subtract 2 tangent thetas. And if you have 4 tangent thetas and you subtract 2 tangent thetas, now you have 2 tangent thetas. Okay? Now I will subtract 2. So now I have 2 tangent theta equals -2 and divide by 2, and I have finally the tangent of theta is -1. So where is tangent of theta -1? Let's see. Its tangent of theta is going to be 1 when you're talking about 45-degree reference angles, and tangent is negative when you have opposites, when x and y are opposites. Here it's x is negative, y is positive. Here x is positive. So those are going to be 45-degree reference angles. And the way we say that is if you list them individually, that'd be 3 pi over 4. Oh, that's not 4. 3 pi over 4 plus 2 pi n, or 7 pi over 4 plus 2 pi n. Now, if you want to condense those, which I encourage you to do, you would start at 3 pi over 4. And since they are 180 degrees or pi radians apart, you just say 1 pi n. So 3 pi over 4 plus pi n. Cool. Let's try a couple more. Get sine by itself. So subtract 1, divide by 2, you get -1/2. I want to know where sine is -1/2. So that's going to happen in the third and fourth quadrants. Sine is negative. And if the y value is 1/2, that means we're talking about 30-degree reference angles. So this happens at 7 pi over 6, and we'll say plus 2 pi n, or 11 pi over 6 plus 2 pi n. So 7 pi over 6 is here, 11 pi over 6 is there. And since they're not pi across, we'll just say plus 2 pi n. Let's see, the tangent squared of x, you would add 1, divide by 3 is 1/3. Then square root both sides, and you get the tangent of x is plus or minus, don't forget that. The square root of 1 is 1, the square root of 3 is 3, is radical 3. So now you need to rationalize it and get, we're looking for plus or minus radical 3 over 3. So you should remember, it's not a pen, the tangent of 60 is radical 3, and the tangent of 30 is the reciprocal of that, which is radical 3 over 3. So all of the 30-degree reference angles is what we're trying to list. So if you draw that, the 30-degree reference angles are going to be like that and like that. So we'll say, if you list them all out, that's pi over 6 plus 2 pi n, or 5 pi over 6 plus 2 pi n, or 7 pi over 6 plus 2 pi n, or 11 pi over 6 plus 2 pi n. If you condense them, you could condense these guys because they're pi across. So we'll say pi over 6 plus pi n, or 5 pi over 6 plus pi n. So that's the condensed version. And then, if you want to get real crazy with it, since this is positive and that's negative pi over 6, you could even go further and say plus or minus pi over 6. So start above or below and then add pi n. And that'll do it. So all sorts of fanciness to get these things. Again, I don't care if you condense it all the way. You should definitely give it a shot when they're pi apart, like the green. The yellow is just kind of for fun. If you list them all out, you know what you're doing. Let's try a few more, and that'll be it for our practice. So we're saying sine squared of x, you would divide by 4 and get 1/4. Then when you square root both sides, the sine of x is plus or minus Square root of 1 is 1. Square root of 4 is 2. So where is sine 1/2? Sine is 1/2 at all of the 30-degree reference angles. So this is the same as this one. So I'm just going to steal this guy and say, hey, here's my fancy answer. Let's just use that as my fancy answer. All of the pi over 6's can be listed like this. Is that one thing? Can I just grab that? There we go. Okay. Same answers as the other one. You're going to see there's a lot of repeat answers because the unit circle is a finite thing. There's only a certain amount of terminal points that we reference. Cosine or cosecant squared. Ooh, cosecant squared. So let's see. First I'll add 3. Now I have 4. Then I'll divide by 3. So cosecant squared of x is 4/3, which I don't even want to deal with this. Cosecant is the reciprocal of sine. So I'm going to say the sine squared of x is 3/4. Once I do that, I think I'll be in better shape. That means the sine of x is plus or minus. The square root of 3 is the square root of 3, and the square root of 4 is 2. So here, I want to know where sine is plus or minus radical 3/2. That's when the y value is the tall side. So all of the 60-degree reference angles. So if you list them out, pi over 3 plus pi n, 2 pi over 3 plus pi n. This is 3, so 4 pi over 3 plus, oh, I should be saying 2 pi n right now. 2 pi n, or 5 pi over 3 plus 2 pi n. So if you go all the way around, you list them out, those are going to be plus 2 pi n's. If you condense it a little bit, you would say pi over 3 plus 1 pi n, pi over 3 plus pi n, or 2 pi over 3 plus pi n. And then let's get real fancy. Plus or minus pi over 3 plus pi n. Hey, that's pretty cool. Okay. Plus pi over 3 plus pi n, or minus pi over 3 plus pi n. That gets all of it. So, again, we're just trying to practice these ideas of condensing them. The most important thing is that you can isolate the trig function and then tell me all of the places, all the angles that give you those points. That's all you got. So good luck with your exercises and hit that like and subscribe button.